So I think this is where we left off, and if it is, good. Anyway, I just left some space here for we're going to replace what we're going to replace x with, and we're going to replace x with 2. And so we have 2 there, 2 there, and 2 there. You don't need to multiply out these binomials. The limit of the product is the product of the limits, and so anyway, you get, I need to change colors here. You get 2 times 2 squared, so 2 times 4 plus 1, and then you have 30 minus 4 times 8, and so 8 plus 1 is 9, and we get 30 minus 32, so that's negative 2, and so we get negative 18. And that's the limit. Okay, so you can see whether we have products, whether we have polynomials, multiplication, multiplying together. Oh, let me scratch that. If we have polynomials, you just substitute what x is approaching. If we have the limit of the product of 2 polynomials or more than that, you still just substitute what x is approaching. And so polynomials really make it easy to find limits. You just substitute. Okay. Now what if you have a polynomial divided by a polynomial? And what do we call that? You should know the answer to that. A polynomial divided by a polynomial is a rational function. So what if we have a rational function? Well, typically, if you have a rational function, you can still just substitute what x is equal to. But if you happen to substitute what x is equal to here, you get 2 squared, right? 2 squared minus 4 over 2 minus 2. And so this becomes a bit of a problem, not too badly here. But anyway, you get 0 over 0. If you ever get 0 in the denominator, do not just say it's 0, because sometimes it is, but many times it's not 0. 0 in the denominator will never make your fraction equal to 0. So the question is, what do we do? Well, in this case, you should be able to notice here that x squared minus 4 could actually factor, and so we're going to simplify our fraction a little bit here, and we're going to factor it. X plus 2 times x minus 2, and that's still divided by x minus 2. So when that happens and the factors cancel, then we just, let me do this down here. Then all we have to do is resubstitute 2 back into what's left over. Okay, so what's left over is your x plus 2, and then we get 2 plus 2, or 4. So the limit is 4. So we can handle it, again, if we have the limit of a fraction. Let me give you guys one to do, or you're probably not sitting there with a bunch of people. So let me give you one to do. X approaches, let's say, negative 3, and let's make that x squared minus 9 over x plus 3. The first thing you always want to check is, so anyway, pause the video and try this one on your own. First thing you want to check is what happens when you substitute in what x is approaching, and when you substitute in what x is approaching, you get negative 3 squared there, and you get negative 3. You could do this all in your head, but anyway, you get 0 divided by 0, and so that means that you need to do something besides just sit there and look at it, and then you can't just say it's 0. But as x approaches negative 3, we have still that ability to factor the numerator, and we can cancel, we can see here, we can cancel the x plus 3's. And then, don't say 0, okay, negative 3 minus 3 is not 0, but we get the limit as x approaches negative 3 of what's left over. Okay, and what's left over is just this nice polynomial function, and we substitute in the negative 3 for that 3 right, for the x right there. Negative 3 minus 3 is negative 6. Okay, don't feel bad if you said 0, because you had an AP Calc student say negative 3 minus 3 was 0 today, but it happens to everybody. Okay, so that's really about it. I'll give you a kind of a more challenging problem that you're going to see in your homework. or I guess the classwork that you're going to be doing. Let's do this. Go ahead and copy this down with me. Okay. The limit as x approaches 2, and we're going to take this big ugly fraction. Okay. So again, we have a polynomial in the numerator, 4x minus 8, right there. And we have a polynomial in the denominator, and you're going to look at this and you're going to think, oh my goodness, this is ridiculous. And you know what, I kind of agree with you. You're not going to ever see anything like this, but it's a good practice with factoring polynomials that have 4 terms. So when you see one like this, just factor by grouping, okay? So understand that when you see one like this, it's always going to be 0 over 0 in these problems in the book. But if you kind of eyeball it, 8 minus 8 is 0, plus 8 minus 8 is 0 up there, okay? And then down here, 16 minus 16, 0, plus 2 minus 2, 0. Okay, so we clarified that. So x is approaching 2, and then in our numerator, let me scratch that, we're going to factor out an x squared, and we're going to get x minus 2, and then we're going to factor out a 4, and we're going to get x minus 2. And then downstairs here we factor out an x cubed, and we get x minus 2, and then we factor out a 1, which is really not factoring anything out at all. And so this is a little review of Algebra 1. So we have the limit as x approaches 2 of x squared plus 4 multiplied by x minus 2 over x cubed plus 1 over multiplied by x minus 2. Well, obviously here the x minus 2's cancel, and what we get is 2 squared plus 4 over 2 cubed plus 1. Okay, 2 squared is 4, 4 plus 4 is 8, 2 cubed is 8, plus 1 is 9, so I didn't write that 8 very well. 8 over 9 is your answer. That's your limit. Alright, yeah, it's kind of a pain. I won't assign more than one of those. Okay, but the main idea here is that you substitute in the value that x is approaching, and when you do that, and you get 0 over 0, you have to do something, and normally that something will be to factor the numerator and denominator, or one or the other, cancel, and then re-substitute the value back in. Okay? So I think that's about it. No, I guess there is one more thing, and I will pause and then come back. I take it back. We're done. So go ahead and do the problems online, and I will see you in class. Have a great night.